program content itself. And if anybody that is IPE here, whether an alumni or a student or a lecturer, I think is something that we should be proud of and continue to celebrate. Once again, welcome to everyone. I can see that our special guests are already present, students that are here, people from other departments, people who are here accompanying the guest speaker. Everybody, welcome. We are going to have an enlightening session this evening. You can be sure of that. If not based on anything, based off the topic, is not irregular. It's not something you see flying around often. So I'm sure that we would all leave here with new knowledge, very much enlightened and also empowered to be better citizens of or better education providers in Nigeria. I am particularly looking forward to the session. I remember that the guest speaker, I don't know if you can recall, but he was a visiting lecturer when I was an undergraduate in my final year. He took us a couple of classes as an invited lecturer from the industry. So I'm looking forward to the session. Everyone, I just encourage us to focus and pay attention as much as we can. I know it's an online event and people usually tend to occupy themselves with other things while joining such events. But as much as is possible, I'll encourage everyone to pay attention. You never know what you might hear, how it would help you. It might help in your next class or an interview that you show up for. You never know where knowledge would come in handy. So I just encourage every one of us to pay close attention to all that will be said this evening. So right now, I would like to invite our chairperson for his opening remarks. We have Engineer I.F. Bello, FNSC, the current chairman of the NSC Ibadan branch, and he would be giving us an opening remark for the next couple of minutes. Please let's welcome. You can just in the chat section put your hands together or something to recognize the chairperson.
Good evening.
Evening.
Our hobby moderator. Sorry, I have two cards this night. In fact, we have another chat online with my president, Nigeria Original president, ongoing. But because I've already committed myself to serve as the chairman of this online lecture, so I quickly deliver my chairman opening remarks. Thank you very much. Ladies and gentlemen, esteemed alumni, distinguished guests, and participants. Hello, can you hear me?
Yeah, we can hear you, sir.
Thank you very much. Good evening and a warm welcome to this 22nd IPEA Alumni Online Lecture Series. It's an honor and a privilege to address you all today as we embark on a journey into a topic that holds immense potential for the future of our higher education in Nigeria, cyber physical systems, CPS. In an era where the digital and physical worlds are increasingly intertwined, CPS represents a groundbreaking model. This system, which integrates computation, networking, and physical processes, are not just a technological innovation, but a transformative force that can revolutionize how we can approach education, research, and development. Today, we stand at this of a new educational era. Our higher education institution must evolve to keep pace with the rapid advancement in technology and the demand of a globalized economy. CPS offers a pathway to achieve this evolution by fostering interdisciplinary collaboration, enhance practical learning experiences and preparing students for the complexity of the modern world. This lecture series aims to exploit how CPS can be integrated into the Nigerian higher education system, addressing the challenges and opportunities that come with it in this integration. The guest speaker will delve into this technical aspect of CPS, its applications across various industries, and the educational strategies necessary to equip our students with the skills and knowledge required for success in the CPS driving world. I would like to extend my gratitude to our great speaker, Damilola S. Olufolaji, distinguished attendants, and all participants for your commitment to this important dialogue. Your expertise and insight are invaluable as we collectively seek to chart a new course for the education in Nigeria. As we begin this session, I encourage you to engage actively, ask questions, and share your perspectives. It is through our collective effort and shared vision that we can harness the full potential of CPS to enhance the quality of education and prepare our students for the future. Thank you for your presence and participation, and thank you for having me as your chairman of this occasion. Let us embark on this exciting journey together. Thank you for listening.
Thank you, sir.
Thank you so much, sir. Thank you for that opening remark, and also thank you for choosing to stay with us and for honoring your commitment to be present at tonight's meeting. Right now, I would move on to, we're supposed to have the special guest of honor. I'm not sure he's present yet, but I see that we have the guest of honor present. So I would like to welcome the guest of honor now, Mrs. Abiodun Alao. She's director of items in UI, and she would be giving her goodwill message now.
Okay, thank you very much. Good evening, everyone.
Good evening,
I want to compliment the efforts of the Department of Industrial and Production Engineering for organizing this Alumni Association online lecture series. I'm particularly interested in the focus of today's lecture, which resonates with the vision, mission, and core business of the University of Ibadan. Well, maybe by way of stating where we are, and then looking at how this is going to be of immense benefit to the university. We improved on. Can you hear me?
Yeah, we can hear.
Go ahead.
Oh, okay. All right. So the university is currently moving from the traditional face-to-face teaching, that is the teacher-centered, to the more dynamic student-centered approaches where the teacher, as we know, is the facilitator rather than somebody standing in front there and dishing out what students should know. But it has not always been like this. Before 2020, the COVID-19 experience, it had always been face-to-face. But a number of initiatives have taken place in the university. We have the Partnership for Enhanced and Blended Learning, which was interestingly led by a member of the faculty, Professor Oluleye, Professor A.E. Oluleye, several years ago. We also benefited from other initiatives like the Partnership for Enhanced Blended Learning, which is most recent in West Africa. Also led, the UI team is also led by a member of the
Hello, ma'am.
Oh, sorry, I didn't realize that. Hello?
Okay. We lost you for a few minutes there. Or like for a minute.
Hello?
Yes, we can hear you now, ma'am.
Oh, okay. Sorry. I think there was a network disruption just a while ago there.
Okay.
So all this form the foundation for what we now call blended learning in the University of Ibadan. After the COVID-19 experience where we had emergency remote teaching. I must mention that this experience actually helped us a lot. And now we have the e-learning policy of the university already approved. So our focus for teaching and learning is that teaching and learning should be a pleasure. And we're actually moving towards what we call smart UI in the university. So from this, we can see the potentials for our topic for today, which is cyber physical systems, the new direction for higher education in Nigeria. Well, I can see that there are many areas where this can really help us. The cyber physical systems can improve smart learning environments, wireless network classrooms, virtual laboratories, the studios, automated assignment generation, and automated grading, and so on and so forth. I do not intend to take over the lecture, but I'm just excited about the potentials that this is going to bring to us. With CPS strategies, we can easily overcome some of the challenges we have had that have been posed by old buildings that are not connectivity ready. I'm sure with this, we will have solutions that will work for us. We will have solutions that can make the entire university even more efficient. So I am positive that this lecture will not only open our eyes to the potentials, but come up with actionable plans that will make University of Ibadan a model for higher educational development in Nigeria. And I want to congratulate the lecturer for today because I know that he had been carefully selected, and all the audience, and also enjoying us, that we give it our utmost attention. And then I wish everyone a rewarding time during this lecture and thereafter. Thank you.
Thank you so much, Ma. Your excitement is palpable and transferable. I'm hoping that more people are now looking forward to the talk even more than they were before you spoke, because of all the possibilities that are within the talk, as you rightly mentioned. Thank you so much. So right now we would have our special guest of honor. He is now in the room. Would have him give his goodwill message in the person of Professor J.A. Olorunmaye, FNSC, the chairman of Korean Engineering Accreditation Committee. So he would be speaking to us now. Welcome, sir. Please let's acknowledge him in the comment section, or in the chat section.
Thank you. Ladies and gentlemen, it's a pleasure for me to be with you in this virtual meeting. We thank the department for working a platform for the alumni to give back by way of lectures like this and in various other ways. It's a good feedback to the department and also a good guide on the direction to go. I hope from the lecture today, we will have some useful input. We are about to review the current BMAS in view of the CCMAS that NUC has just developed. The current BMAS 2017 edition is overdue for revision. So I hope we'll be able to have a few things from this lecture that will be a good input for review of the curriculum we will put in the current BMAS. if not for all the engineering programs, at least for mechanical engineering or industrial and production engineering program. This type of forum is highly encouraged in this OBE implementation, outcome-based engineering implementation. It is expected that there will be very strong link between the departments and the alumni, the people who have passed through the department as students, and now they are working as professional engineers. So this kind of forum or this kind of program strengthens that link, which will help you to meet some of the outcome-based education implementation requirements. So this type of initiative of this department is really encouraged. So we look forward to having an interesting lecture this evening from the guest lecturer, and we hope that some of the things discussed will be useful input in our review of, in the preparation of 2024 edition of current benchmark minimum academic standard. Thank you for inviting me to this lecture. We look forward to a great lecture this evening. Thank you.
Thank you. Thank you very much, sir. Like you said, this couldn't have come at a better time for Koren. It's perfect timing and perfect setup for everything that Koren is trying to do for education in Nigeria. So we have heard from our guests and our special guests, and we are
Thank you.
now we would have
perfect setup for education.
There's an echo somewhere. Is that okay? I think it's gone. Thank you. Now we are getting ready for the much anticipated talk. Yeah, and I would like to welcome the person I'll be reading the citation of the guest speaker. I don't know if there are any students here, but if there are students here, then the person I want to introduce, everybody knows. We went through his office while preparing for our SWEP or SIWES, whichever one it was, but he is a very prominent part of every industrial engineering student's undergraduate experience. So I'd like to welcome Engineer Okwadari now to read the citation of our guest speaker.
All right, thank you, Dr. I hope I'm audible.
Yes, sir.
Am I audible?
Yes, sir, I can hear you.
Hello. Okay. All right. Good evening, everyone. Good evening, everyone. It's a privilege to be reading my friend, my colleague, and namesake citation tonight. I would like to share my screen. Please let me know when you can see the screen for the citation. Okay. Can you see the screen now?
Yes, sir. Yes, I can.
All right. Thank you. is a Nigerian educator with a background in industrial and production engineering. He earned his Bachelor of Science degree in industrial and production engineering from the University of Ibadan and a postgraduate diploma in education. Mr. Olufolaji began his career with a role as the head of technology and mathematical science department at Calvary Arrows College. He has top 5. He has trained many students on to win scholarships, study just University College, University of Toronto, Skulltech. Since 20, he has also
I am guessing that the network kicked him out. But all right. Maybe I'll just welcome. There was a bit that was said about our guest speaker, and I guess as time goes on, or as we hear from him, we'll be more acquainted with him. Or is Engineer Akwadare back? He's unable to connect to audio for now. I think I'll just
okay. My network.
He's back.
Sorry, can you hear me now? My network went out.
Yes, I noticed. You're welcome. We can hear you now.
Hello, can you hear me now?
Yes, sir.
Hello. Hello, can you hear me now?
Yes, we can hear you, sir.
Okay. Please, probably I might have to stop sharing the screen. The network is bad here.
Okay, that's fine.
All right. Since 2020, he has also been the director of Peace House Innovation Center of Excellence, where he has led initiatives in strategic planning, research management, and industry collaboration. Additionally, he has been an associate in production engineering since 2021, focusing on courses such as computer-aided design, manufacturing. Notable projects: Assistive System for the Physically Challenged 2012, designed and built a device and software to facilitate computer usage for physically challenged individuals. This project won first place at the National Science Fair and selected to represent Nigeria at the International Science Fair in Sevastopol, Ukraine. Gesture Control System for Physically Challenged 2014 developed a device using 6-axis accelerometers to capture head movement and control home devices. Rapid Response for Accident Prevention and Detection 2014, a device to track car movements, detect accidents, and report them for rapid response. Other notable projects: low-cost electromyography EMG sensor 2016 led a team to develop a cost-effective device to detect electrical activity in muscles recognized by synaptics and INCOS at Intel ISEF in Phoenix, Arizona. Smart solar-powered vacuum-assisted closure 2018 patented. Developed an intelligent vacuum-assisted closure machine for wound healing, awarded a patent in 2022. Smart solar-powered ventilator 2019 to 2020 patented. Led the development of a solar-powered ventilator, winning first prize in Nigeria's largest science fair in 2021. And last but not the least, automated fish farming system 2021. In addition to these highlights, Mr. Olufolaji has over 20 other projects to his credit, including medical devices for hospitals such as University College Hospital and the National Orthopedic Hospital in Enugu, which have been tested and are now going into production. Mr. Olufolaji's achievements are further highlighted by several awards and recognition, Apart from the patents and prizes he has secured, he was also honored as the Seed Training Facilitator of the Year by Schlumberger Excellence in Education Development in 2015. Outside his professional achievements, Mr. Olufolaji is actively involved in volunteering and STEM advocacy. He has served as a seed training facilitator, a science fair coordinator for Benue State, and a patron of Exploit STEMing, an NGO promoting STEM education among young people across Africa. He has also been invited to give TED Talks, including at the Fourth Industrial Revolution and Evolution of Manufacturing in Nigeria, hosted by Innovate, the Israeli Embassy Initiative in Nigeria. Mr. Olufolaji is happily married and has 3 children. Ladies and gentlemen, join me as I welcome our guest speaker tonight, Mr. Damilola Seun Olufolaji, to lead us in the discussion of his lecture. Thank you.
Thank you very much. Ms. Dotson, am I okay? I can go ahead now. Thank you very much for that. And I must again give all gratitude to God for whatever achievements we have made. It's been Him. And I must say I'm grateful for the opportunity to be the guest speaker at this particular alumni lecture, the 22nd. I want to indeed appreciate all our other guests and all our distinguished personalities on this platform at this time, the chairman of Korean Ibadan branch and all our other people in the house. Thank you very much for being here today. I'm trusting that we will be able to do justice to this critical issue that we'll be looking at together today. Thank you very much. Please permit me to quickly recognize the presence of some of the people we work together in making what we do at Peace House Research and Innovation Center of Excellence possible. The approach we're looking at learning for students, the people that are making it happen, assisting us to make it happen effectively. We will work together on this team. Let me acknowledge the presence. I think in the house we have the CEO of AXA Mansard. AXA Mansard, if we know, is the largest health insurance company in Nigeria and West Africa, in the person of Mr. Tokpe Adeniyi. Is in the house here. I'm not sure whether we'll be able to see him. And then, okay, he's there raising up his hand. He's the head of our leadership and entrepreneurship development initiative for our interns, for our training programs, because we have a lot of priority placed on leadership and entrepreneurship. You must be able to take your goods to the market and make it profitable and make it marketable, and understand how to lead people, how to run an organization if we'll have change in Nigeria. So it's not enough to be an engineer that can produce something. You must know leadership, you must have leadership skills, you must have entrepreneurial skills, and Mr. Tokpe Adeniyi helps us to head that arm of our work. He's here in the house with us. Also, I would like to recognize the presence of Mr. Inyaboyeji. We know Inyaboyeji is the co-founder of Andela. Andela, the largest outsourcing firm in Nigeria in terms of IT. And is also the co-founder of Flutter Wave. I'm sure many of us use Flutter Wave as a payment platform. He's the CEO and founder of Future Africa, a venture capitalist organization. So he's also part of our team to help our interns understand how to turn your product to something that is profitable, something that is marketable, something that the venture capitalist can look at and say, yes, we think we have something here. So he helps us to give all those competencies to our interns. So they are ready from the moment they graduate to be able to meet with venture capitalists to fund their startups and make it profitable. So he's also in the house with us here. And also in the house with us is Mr. Musbal Asisi. He's the CEO of OPEX Consulting. He's helping us to head the IT input of our entire work, the trainings we offer in our organization. So I'm happy they're able to join us here this evening. We are not able to spotlight them, but if you look up, you'll see them right on the screen. Thank you very much. I would like to go ahead straight away to share my screen. All right, can we see my screen very well?
Yes, sir.
Okay, thank you very much. All right, so we are looking at cyber physical system, a new direction for education in Nigeria. The last lecture we had to do with smart manufacturing, which is a major subset of the cyber physical system world as a whole that cuts across various industries and various aspects of human endeavor. So we'll be looking at this today, and I'm trusting that we'll be able to do justice to it in the little time we have to move on. All right, I'm seeing that. Sorry, just a minute. I'm seeing that Professor Adegorite Adeoye is with us in the house. Professor Adeoye.
It seems like network has, okay. Sorry, you're muted. Okay.
Okay. Sorry, I had to change network. It seems the network I was using before. I have two on standby. We know what happens in Nigeria. Sorry about that. So I have two on standby. If one doesn't work well, I move to the other one. So I'm on another network now. Sorry. Okay, so I think I successfully introduced Professor Adegorite Adeoye, a former IPE student himself. So we are moving ahead. Let me see. I should share my screen again. All right. So introduction and definition. First, we'll be looking at CPS in the Nigerian education, both as what I call an object and a subject, or maybe I should call it both a means and an end in itself. A means in the sense that our one of our guests has spoken about, the head of our items. as a means of achieving education, but in itself as an object, what we ought to learn. Those are the two angles we are going to be looking at CPS today with our educational view and looking at Nigeria particularly. So CPS is an important ingredient we need to look at for our students to be familiar with if they are going to be abreast with what is happening in the 21st century and beyond. So we'll be looking at all those details. So these are outlined. We have introduction and definition, components and key features, applications and necessities of CPS, integration of CPS into the engineering curriculum, platforms and resources for training on CPS, and then we have challenges and considerations. Then we share a little bit of our experience at Price. We look at IP as a focus, and then we come to our conclusion. So introduction, what is CPS? Cyber physical systems. It's the convergence of physical systems with computing and communication capabilities. We've known about the third industrial revolution, which is all about automation, where what you call the PLCs became very, very ubiquitous, and that's what we began to use to control the entire manufacturing process. But then we moved beyond that now to where we are today, which has to do with communication coming into the mix, where decision making is no longer in some isolated locations or just resident in the machines, but data comes into play, and access to data becomes necessary. That's where the communication capabilities come in, and the computing capabilities come in. So you see what we call artificial intelligence in its various facets coming into play, machine learning coming into play as you look at both what you call deep learning and then the aspect of reinforcement learning all coming into play to make systems much more intelligent and much more supposedly independent of human input as much as possible. Of course, human can't be taken out of the mix, but then systems are better able to handle such tasks that are very challenging for human beings to do, especially repetitive tasks. So we have that coming in with what we call cyber physical systems. So this integration marks a significant paradigm shift in engineering and industrial practices, where traditional systems are enhanced by advanced computational algorithms, real-time data processing, and seamless connectivity. So that's what is happening today. That's what we have right now. A situation whereby we have connections. So the typical way, the most common way I can say you can see this is where you have your Google Translator or Google's speech-to-text on your mobile devices. The information used to process whatever you are doing at any particular point in time is no longer resident on your device. It's now resident in the cloud. It's now dependent not on the computational power of your device, but on the computational power of very big servers located far away somewhere across the world, crunching the data, analyzing the details, and getting accurate results back to you in real time. Of course, before the advent of this will have been difficult, if not for the progression from 2G to 3G to 4G networks. And now we are talking about 5G networks. This communication makes this possible. So let's quickly move ahead. So what is CPS again? Complex integrated systems that blend physical processes with computational elements and networking capabilities. So your wide area network, your LAN, a CPS can actually be located within a small factory where they have their own local cloud and they have their own local area networks and everything contained together. And but that means you need to have good computational power in your machines. So that's what CPS has made possible. And why is this crucial for me, and why is this necessary to begin to look at as we look at our curriculum? What does our curriculum seek to offer? Do we have this properly integrated into the engineering curriculum? But we'll be looking at that further. So components of CPS, the physical, the computational, and the networks. Of course, the human factors come into play around this as a fourth element, but generally, we're looking at the physical component, the hardware, computational component, the processors, and then you have the network. So physical component includes sensors, actuators, machines, all that. While there are sensors are the inputs that are sensitive to the environment and they take in data. The actuators are the ones that now perform actions. They are more like what we can understand as the output. And the machines themselves are what now use all this all together. So the machines get to sense and get to perform tasks based on what the computational system does with the data and the feedback from the actuators. So vehicles, buildings, and other infrastructures are now getting involved. So you have smart buildings now, as you have smart vehicles, and you have smart industries. We delved into that last month, when we had our first, the 21st lecture, and I won't be taking too much time on that. So you have embedded systems, processors, controllers, and the algorithms that run inside them. So controllers are different from processors. Microprocessors are more powerful, more bigger, but they have their use cases. Controllers are smaller, lighter, less power demanding, and they have their own use cases also. You don't compare the two of them. They have their own worlds. All these are what is present in embedded systems that now have the ability to actually take decisions on their own based on the algorithm. You have the wired and wireless networks for communications, as we see. So on the whole, you have people and machines, computer science, software engineering, physical environment, the internet, sensors, embedded systems, all of them integrating together into an internal circle of the middleware, the synchronization systems that must take into account security, cryptography, because again, one of the major challenges we now have as things are getting much more connected with the Internet of Things and the industrial Internet of Things, the challenge has shifted much more to focus on the security of these systems. Because now, actually, it's possible for someone to lock you up in your car remotely if you are not very careful. If he successfully hacks into your connected car, like a Tesla car, and other cars like that are existing right now. So you have control done by embedded systems, and the people interact with this. That's where the matter of HMI, HRI come into place, human machine interactions, human robotic interactions, and all that. And everything has to happen in real time, and that is very much dependent on the networks. So moving ahead, what are the key features of CPS? Real-time interaction. Real time. That means that sorry for that. Sorry, Dotun. I hope I was audible and clear before the network kicked me out.
Yes, it was just a few seconds.
Okay, thank you. So let me just share again my screen. Sorry, can you see my screen now?
Yes.
Okay, thank you. So I was on real-time interaction. I talked about that and the need for real-time interaction being critical because there are now more critical systems that need quick response. A delay in a few seconds can be very, very consequential. So it becomes quite important that we can have real-time interaction. That depends on the networks, which creates the interconnectedness and gives the autonomy of the system. So it's able to take decisions on its own. It's able to run independent of human input. So you have so right now we have situations whereby you can place an order for a device, for an item from a factory. You are placing your order on the internet, on the web page or mobile app made available by the company. And as you are placing your order, the order is not going into someone's, even though it goes to someone's email, but it's not going to someone's email for action. It's not going to someone's email for consideration to now place the order on the factory. The order goes straight to the factory, goes straight to the manufacturing process and assembly line. The order goes straight like that. So your mobile app communicates with the factory without any intermediary. So the people around the factory just get to know, okay, these are the number of orders and the machines are already producing them, just like that. So that level of autonomy and adaptability to respond to things are now there. So one other critical thing that CPS gives us is safety. Now, why is safety more crucial with CPS now? Is because with these systems, sensors are available. You can pick things before they happen. Okay, so like we were talking the other time, Engineer Padare was reading citation. So at some point in time, we developed a device for rapid response and accident prevention. And so what does this device do? This device, we designed it such that you are driving in the night and you are not familiar with the terrain. It has a record. This was some 10 years ago before Google, I think 8 or 10 years ago, before Google finally had on their maps now, your ability to navigate and show you your road. So this device is able to help you to know the road terrain. So if you're approaching a bad spot, a pothole, and you're driving at night, it's able to give you signals, a beep, to let you know you are getting closer to a particular bad spot and you need to slow down, even though you cannot see clearly. Because the cloud computing data is available for the road network. The device can communicate with the cloud to pick that. So alternatively, you can download road terrain into the device and have the GPS location of different ports. And this device has a GPS capability that knows your location, knows the data for the location of the spots, computes your distance to the spots, and then lets you know once it's within a particular range in terms of hundreds of meters. And then you'll be able to slow down, and therefore safety is much more assured. So that's some possibility with the cyber physical systems that we would not necessarily have on our own. So again, fault tolerance, error detection is now possible because of this. With sensors right there on the job, all the time, every second, monitoring things, even things that you cannot even as a human being see, they're able to monitor and all that. So even in healthcare, it's the same thing. Now we have a lot of more reliable systems of performing operations, surgical operations, because you have robots that are very, very stable. I can say, even if you have Ben Carson with very gifted and stable hands, a robot has more stable hands than you. We're working on a project with some of the interns that came for a training that we just concluded a few days ago, yesterday, and we're developing a tabletop CNC machine. And we were able to achieve an accuracy of 1 mm divided by 360. 1 mm divided by 360 was the accuracy we could be able to achieve. So imagine that kind of stability, 1 mm divided by 360, that kind of stability. So the device can move that step 1/360 mm. You can imagine that level of accuracy. So that is possible now. So scalability and flexibility. CPS architectures are designed to be scalable, from small localized developments to large-scale implementations spanning multiple geographical locations. They offer flexibility to accommodate diverse applications and evolving technology advancement. Now, you know what happens now with CPS is that 2 factories can actually communicate together, and they can leverage on each other's capacities real time. So this factory has a problem on a machine. Sensors already detects that. Downtime is already computed. Production losses is already automatically computed. So volume that will come out as against what is expected is computed in real time. And another factory is communicated with that, okay, you have this capacity, even though you are limiting your production to this capacity, you have to step it up to make up for this deficiency. Now, the logistics of transportation will come in to get it to the customers and all that. So all that scalability and flexibility is now available with CPS systems. All right. So application of CPS, smart manufacturing, that was our topic last time we're talking. So I won't talk a lot about that, but it's just along the line of what I've already said, where you have the entire manufacturing process being very smart, being very intelligent, being connected, where 2 machines are talking to each other. That brings in edge computing. 2 machines are talking to each other, and it's a machine in the particular assembly line that has a problem and is needing to slow down, can talk to the rest of the machine in the line to stop production so that there's no clog until it's rectified. And then when it starts working again, it talks to the others and they continue production. Where you have the old assembly line being monitored, being checked all the time, tools being used, they are being monitored, they are being checked. So you are not stopping the production system to check whether it's time to change a tool, to change a part, to change something. Sensors are dynamically measuring all this. And once it's time for a change, alerts are sent. Once it's getting close to the time for a change, the machine places an order for a replacement automatically. And that is honored and everything comes together. So autonomous vehicles is something we have been hearing about. Tesla is at the forefront of this with all the smart cars that even get updates over the air, OTA updates that solve problems rather than sometimes having to physically do a recall. And talking about that briefly, one of the key things of CPS is this ability to do over-the-air updates that correct problems. Now, when you have problems in a CPS system, when you have problems in a device that is remotely located somewhere, there are sometimes it's possible rather than do a physical change of something, you could actually do a software change that will address whatever challenge is being observed. You could do that. Just a software change can take care of whatever challenge is being observed. Cloud makes this possible and therefore makes life a lot easier. So you have smart grids and energy systems. So here at Price, there's Peace House Research and Innovation Center for Excellence for full. We have a 120 kVA system that we set up and we installed, set it up to power our facility. And that was a learning opportunity for our interns. And then part of the project was
okay.
Sorry, Doctor, thank you. I hope it doesn't go again before I go. But was I audible?
Yes, sir, you were.
Okay. So what we're doing with our smart grid is renewable energy is the way to go. Renewable energy is talking about global warming, sustainability, and all that. Renewable energy is the way to go. But renewable energy has a major problem in terms of management. The cost of renewable energy is so high if you want all kinds of problems, which may be occasional, which may be random. So it's too costly to put a lot of funds into a robust system, which robust capability would only come into use maybe once in a long while, just once in a long while. So to put it to context, you need to develop a system that costs 100 million naira to manage a place, to power a place. And so the capacity given you, let's say it's 100 kVA, and that's sufficient. But then occasionally faults take place. People put on heavy loads on the system at the same time, and all that happens. And to mitigate that, you need to increase capacity to 200 kVA. So essentially, you'll be looking at 200 million naira. Now, imagine that need only happens maybe 4 or 5 times in a whole year. Now, it doesn't look like a good economic decision to, because of that, pour in an extra 100 million naira, when 100 million naira would have solved every problem except for those occasional situations. So what do? You need to find ways of making sure those faults or those overload or those excessive usage at the same time does not happen. So what are we doing about this? To be able to solve the problem of energy for Nigeria and for Africa as a whole, what are we doing about this? We are deliberately now creating devices that makes microgrids smart. That's one of the things that our students, our interns have worked on. The first set, the second set are continuing on it deliberately now. So they are developing systems that make the grid smart, that communicate with each building, each house. So you have this kind of special meters in each house. And these meters now communicate with the grid. The grid there, you have sensors measuring your battery level, your solar insolation, measuring overall power usage and all that. And as the sensor measures all this, is measuring what power as against what is demand in the different locations where the power is getting distributed to. And so the meters in each house can actually reduce the usage of power by each house or each location. So you know that, look, I can't put on more than this load at this time so that it doesn't crash the grid. Of course, the meters themselves
Hello, sir.
Thank you, Dotun. So, sorry, so where was I?
You were talking about the meter, the smart meter for power.
Okay, good. Microgrids, yes. Thank you very much. So with these meters, and other devices on the network. We have intelligent contactors at different locations that can immediately isolate an area, because what we've observed happens is that if there's a major fault somewhere along the line, it comes back to the grid, the entire three-phase system shuts down. But if you're able to isolate such problems and not allow it to come back, even in a three-phase system, you identify each phase and each location, you are saving the system. And if you are able to, with a smart meter, actually regulate for different times of the day. So for example, in the daytime, we have a lot of solar insolation available, not like at the nighttime. So at that time of the day, you want people to have a lot of power to use. But you don't want them using some devices at night, like ironing and all that. So a smart system where everything is one connected whole lump, where the individual meters are connected to the grid is talking to the meters are reporting back to the grid, the different substations have their intelligent devices connected to the grid, talking together, means that this entire grid will be more robust and more able to serve us better, more able to help serve better. So that's what we are working on right now at Price, and that's part of the benefits of CPS, because such renewable energy systems that sometimes look as if need a lot of money to be able to run and to be able to kick off and be able to meet demand can now be scaled down and be more economical and be more possible to go with. So healthcare systems are also there using CPS. It's very common knowledge now that you have robots performing operations now, and you can actually be across the world as a consultant, doctor, and you are able to actually follow up with an operation and make inputs and follow everything in real time. In real time. So that is becoming more economical and much more sustainable because we have this connectedness. And so there's no wastage. So you have places where street lights should come on at particular time of the day, or when movement is observed, water should run when someone is actually there needing the water, and all that. And AC should be on when somebody is in the room and all that. So that's part of what CPS has made possible. Now, I will just quickly take us through a video. To see, at this point, I want to quickly move into our need for CPS education. And I just want to take you to a video to show what India is actually working on. I would stop sharing that screen because that slide doesn't have embedded animation. And I'll share another screen for us where we can actually see what I want us to see. So just a minute. Okay, while it loads, I think I'll just go ahead while it loads. It looks like my network is a bit poor this evening. So I'll just go on. Nice. This thing, okay, don't worry. I think it's connected. Airtel is not doing well tonight at all.
Yeah, sorry about that.
Okay. Okay. All right. Thank you very much. So going into the reason why now, why is it a matter that we needed to look at considering our engineering curriculum in Nigeria picking up these things? A few years ago, we went over to UCH, took a tour, and what we saw was quite unfortunate and disappointing. We saw lots and lots of equipment, lots and lots of equipment that are just there and they are wasting because something small got wrong with them with regards to the microcontroller or the electronics. Now, the challenge that our traditional biomedical engineers are having right now is that most devices now have become much more microcontroller based. So it's a program running inside, it's a smart device. And so the traditional way of repairing things is no longer working, is no longer possible. So, okay, thank you. So it's no longer possible to fix these things. So many times you have to send them back. It costs a lot of money. I remember we were at UCH and we saw an autoclave that cost about 30 million naira as at that time. And it had just worked for 6 months. Every other thing was working fine. It's something that has to do with somewhere between the code and the board, the microcontroller board. And so, unfortunately, nobody could do anything about it. Shipping it back to Germany was going to be a big problem. Getting it fixed here was a problem. And it was just lying there. And for me, it's a big challenge because right now, the dollars to keep buying these things are not just there. We all know what is going on in Nigeria right now. And so it's quite painful to see a lot of devices as we go from one hospital to another, as we collaborate with them to work on some things. We see the same story from UCH to the National Orthopedic Hospital. You are seeing equipment, and sometimes you see some of these doctors that want to work and help the sick patients. I remember the pediatric doctor in UCH was showing me the baby incubators and the baby ventilators. And it was just unfortunate that you have lots of them that are still looking new, still looking good, but they are not working. The physical aspects are still fine, but unfortunately, something inside the brain is not working. And it's no longer the basic transistors and the capacitors and things like that our traditional technicians know how to work on. So that led to raising a lot of questions and finding out, why are we not making our own here? Why are we not solving our problems by ourselves? Why are we not making things that meet our needs? And that's why our education has to change in Nigeria. That's why we have to take a new approach to education. That's why we have to think outside the box. I was very excited when I was listening to the head of items talking about us moving away from the teacher-centered learning to the student-centered learning, where we are guiding the learner in discovering knowledge. Now that has become very, very critical. So that, because the kind of learning that is needed to catch up with the pace of things right now is beyond what we can just lock up within our natural capability. The lifespan of knowledge has reduced drastically. Before, the knowledge you have could last for 10 years and is still relevant. But now, things are happening so fast. New things are coming up so fast. And so it's becoming essential to have a means of getting students educated with these current technologies in a rapid way. It has become essential and it has become so crucial. And at Price, that's part of what we are doing. That's part of what we are pushing. That's part of the need we see and we are rising up to change the way learning actually takes place and to engage our students, to engage our interns in practical problem solving as an approach to learning, not just learning some basic things. After you've done the basic things, what problem can you solve? What are you looking at to change? Now that has become a need for us right now within our educational setup. Sorry, I want to be sure I'm still being heard.
Yes, sir.
Yeah, you can hear you. Go ahead, please.
Okay, thank you. So we got to Usage, got talking to them, and that led us to develop a few things that they were able to use in the theater, suction machine, vacuum assisted closure machine. And we had to develop this to meet our own local needs. So we had to develop one that has the capacity to last for 18 hours on a single charge, whereas the traditional ones they've been having are those that you must plug to power before it can work. The CMD was asking, can you give us 50 copies of this? That's the pharmacy. The new CMD picked it up and took it to medicine. He's not in surgery, he's in medicine. So as he came on board, he said, no, this device must be used in my section. And he took it to medicine. And it was exciting to see that we could be solving our problems. And we just need to start somewhere. And we just need to look at how to incorporate this kind of learning into our entire education. And it doesn't have to be, like I said earlier, localized within what we can, within our capacities produce. We just need to be able to guide the interns in the direction of this. We just need to be able to show them the way to go.
And we're back in third quarter planning. Adams is quarterbacking this project, and she's looking pretty tired, Jill.
She's stuck, Bill, and that deadline is looming.
It looms for us all, Jill.
Sorry, just a minute.
She just pulled up Grammarly.
That is a smart move by Adams. Grammarly is an AI writing partner that helps you make your point.
Look at that, Bill. She just asked Grammarly to help her write a summary of her doc, and she's shortening it. Beautifully done.
And she sounds like herself, calm, convincing, and also like you trust her to look after your cat.
100%.
Okay. So let me quickly show us what I've been able to get a video.
Did you know that it is possible to detect traffic
in I'm not sure my audio was shared. What they are doing in sorry, Dotun, did you hear my audio when I shared?
We heard the audio, but we didn't see the video.
Okay, good. Okay. Can you see the video now?
Yes, yes.
distant control rooms using roadside infrastructure? That doctors can monitor cardiac patients via specialized mobile apps? Or were you aware that the Delhi metro train you may have traveled in was perhaps the driverless automated train introduced in 2020? Well, the cyber physical systems, or CPS. In turn, it is part of the fourth industrial revolution.
Oh, I think the network couldn't take the video.
Okay, thank you. Just send the. I'll send the link to you.
Okay.
Okay, I've sent the link to you.
Oh.
But we can look at it later. But that's what India is doing. India, in every institution across, top institution across the nation, they have what we call research facilities set up, startup facilities set up, and they are deliberately putting emphasis on cyber physical systems. They are creating multidisciplinary approach to learning. And now, why this is important for me for industrial and production engineering is because IPE has been at the forefront of a kind of multidisciplinary approach to learning, but now our spectrum has to change. Our spectrum has to go beyond where it was before. There were some basic things we necessarily did, but it has to broaden to all the fields that involve cyber physical systems. So, and that broadening now is a responsibility that we must take, within IPE as we look at the fourth industrial revolution and our place and our role in creating systems that are safer, more efficient, more reliable, and all that. So our students need to be up to date. Now, we are far behind in Africa and Nigeria in particular, but if we do not immediately move right now and begin to change our approach to learning and begin to expose our students deliberately to these new technologies, we will be farther behind in a few years from now. The speed is increasing, but the CPS environment and with the way things have emerged are giving us an opportunity to perhaps in a bit of a way bridge the gap and solve our own local problems, solve our own challenges, and change the challenge of the Forex and all the challenges that are economically motivated that is around us, all the limitations that are there. And all the, and it transcends into agriculture, health, everywhere. So like the example I was sharing about what was happening in UCH, for example, and some other hospitals like that, a lot of money has gone into this equipment. New money is not available like that. Yeah, the old ones are there just facing us. But if they were locally developed, they can be locally maintained and fixed. I remember our working with usage, we developed, sent to them, they used it, observed some things, sent it back to us, we worked further and sent it back to them until we had a very good product and they were happy with it. So it's becoming a crucial need for us to indeed be able to solve our problems locally, and we have nowhere to turn to than the academia. And I feel industrial and production engineering have a critical role to play in making sure that this happens. I feel we are responsible for that kind of learning. I'm happy, like I said earlier, that the learning environment is becoming e-motivated. We have e-learning happening. Now we have to increase this e-learning approach to, for example, at Price, we have some relationship with Cisco, for example. And one of the things we do is we get our students, okay, take this course on Cisco and bring in your certificates at the end of the course. We have somebody that is a Cisco expert that helps to check that. So there are needs definitely for collaborations. There are needs for affiliations that would give room for exposure for these things to happen to our students. And then they will be able to move further and catch up with these things. There's need for possibly international affiliations. And like I was sharing earlier, for us in Price, some of the people that take some of our courses come from across the world. And they have a virtual lab where they connect with our students and they handle whatever they are doing, supervise their projects, and all that happens. So it's possible, it's doable. IP has a lot of a large alumni across the world who are in different places. We need to begin to think about how to incorporate our alumni with their competencies into the learning environment that our students are exposed to be able to bridge the gap that is existing, and therefore salvage Nigeria from the unfortunate situation we have found, ourselves in. Let me just quickly run through this. So I think I'll just delete this video. Okay. Sorry, the video I was trying to show is limiting the system, so I just deleted it. So, okay. All right. So it's incorporating into the curriculum helps us to have hands-on experience. And part of what I see we need to begin to do is have, I know we have been looking at project-based learning, as the chairman of Korean was saying about the outcome-based minimum academic requirement that we're looking at. I'm looking at a need for us to begin to engage industry directly. Students shouldn't be doing projects that are just solving problems that they just come up with. Let it be solving problems that is real and around us. It's not out of place to take students to a place like UCH, for example, look at some things going on there and challenge them with what they could come up with as a project that they could do that could meet the need of the society at large. That is becoming very necessary. I think that's an approach we need to pick, because now we would have much more relevance for the industry. One of the major challenges we've had is that it is seen as though students graduate and they can't fit into the industry because they don't have the necessary skills and competencies to meet the need on ground. So doing this deliberately, incorporating CPS into the curriculum, first as an object, beyond a means, will begin to help us have students that are relevant to the needs of society. So it's not that there are no jobs, particularly, even though, yes, we know that jobs are few, but in most cases, the graduates we have are not suitable for the available jobs. They are not meeting it. And a major thing I want to also push for us is we need to begin to look at how to have innovation hubs, startup hubs, such that students don't just do projects. They can be able to create a startup out of a product that they design. So for example, at Price, our first set that graduated last year, that worked on the renewable energy smart grid system, immediately they finished from here. They are graduates from different institutions that met here for the internship program of 2 years. Immediately they finished there, started up their own energy company. Immediately, they are already running, they are already working, and they are now focused on research just in the energy area, solving problems. They are doing research on incorporating not just solar, but looking at, okay, what's the viability of wind in some locations in Nigeria that can be hybridized with solar, and they are working on how to create a system that can be connected together like that. They are doing that, and they are moving on, and they are solving problems for people in terms of energy demand and all that. So we need to have such possibilities within our departments where students can actually create products that leads to startup. And then we need to bring in the industry, just like I was introducing to us at the start, that we have, or as one of our resource persons, the CEO of Future Africa, a venture capitalist company, and a serial entrepreneur, a serial startup founder, co-founded Andela, co-founded Flutterwave, somebody that understands the startup environment, so as to give our students that kind of idea. Because if we don't have startups around products, we cannot solve the problems around us. We can't meet the need. We can't change the narrative. We can't cause a paradigm shift. We will always be in the, sorry to say, Nigeria is in the economic slavery mode. Slavery has ended, but slavery continues. Slavery is history, but slavery is with us right now. Economic slavery is what is happening right now. And that is bringing a challenge to us. And even though, yes, the government, we're looking to the government to do a lot, and the government appears to be having a lot of challenge, solving all the problems that are all around us, I feel the academia can begin to deliberately create that environment where we have students that are liberated and are able to cause a change to happen. We only need to guide them. We only need to create the right atmosphere for them. And we may not be thinking about so much money. We just need to create that atmosphere where they know the right kind of knowledge to be exposed to, and we are giving them the right push to get that exposure. So that's what we do in Price. We have a multidisciplinary approach to learning. We create environments where students learn a lot of things on their own, and we guide them. I tell them, we can't teach you everything, but we can teach you how to learn so that you can learn whatever you need to solve any problem that you meet anytime. Problem-solving approach is key. Project-based approach is key. So introducing CPS content early is important. Offering specialized electives or concentration is very important. Hands-on experience is very crucial. Projects should start happening from day one that students enter the university. I know that, for example, one of my students that went to University of Toronto in Canada, from the first semester, she was confronted with a project to work on, solve a real problem. They gave them a case study, solve this problem. Can you develop a product that solves this problem? From the first time they entered university. And that created a kind of thinking for them. We need to collaborate with industry partners and so that I can provide case studies and all that. And we have more guest lecturers to help us know what is happening in the industry, what are the needs there, so that students will know what is the need that they should be thinking of a solution for in their projects. Projects should happen almost all along the way for students. So now quickly, there are available resources that we can begin to expose our students to for this knowledge in CPS. We have simulation softwares from Tinkercad to Fritzing to Workway to Proteus, and lots of them are like that are available online. I can tell you, our students, we don't actually need to sit down with them and teach them things one-on-one. There are online platforms, lots of information are available. You just need someone to curate it and give them instructions. This and this should be what you're exposed to. And I feel it's not out of way that some of our courses could have some of these online courses as part of your content and part of what you assess and part of what forms your grading for that course. So we could have some of these online courses that is available, whether on Coursera, EDX, as I'm showing you there. And we are engaging students. So we have this course from Cisco that's from Curtis University on IoT that our students go through, from big data to sensors to everything. They go through, they bring in their certificate showing that they've gone through it. They have practical sessions that they are supposed to go through some of the components. And then we grade them on that. We say, okay, yes, you've completed this as part of requirements we have created and all that. So I think, like I said, I'm encouraged that the items head is telling us what is happening and what we are doing. And I think we can expand it to this kind of approach. So these are some of the resources available online that we could use. And some of the academic institutions that do a lot of things in this line that could be very, very, helpful to us. And they are there. They are there. We only need to guide the students there and create an environment where that's what we are requiring of them. So we have organizations that have things on this, like IEEE and all that. And we have channels, YouTube channels, Coursera YouTube channels. They are there, and there are lots of things we could pick from there. So there are challenges. I wouldn't have time to run through that now because of our time, but security challenges and private challenges are there. Like I said earlier, once you are going online, once you are doing things in a connected way, you have to look at this. Integration, standardization needs to happen where different devices can talk together and they can operate together. Scalability and adaptability for different environments. Real-time constraint, of course, you need to have real-time data flow, but like I've been having challenge with network here. It's a matter. Network being down can mean a lot of problem for a CPS system. So there are developmental and deployment challenges, and there are human factors and usability challenges. Sometimes to get people to use new systems can be challenging, but then if we do our work very well with what you call some social education and all that, we will be able to go through that. So at Price, I've already tried to run through some of these things. Our educational approach that I feel should be what we need to begin to look at. We've tried it. It has worked for us in terms of what the output has been. And I feel it's what should be the new approach to education right now, especially in engineering, and particularly industrial and production engineering. This should be a critical approach that we are looking at, where we are bringing in industry partners. Like I said, we have people that understand leadership and entrepreneurship. We have people that understand venturing and starting up a company and all that. And we are not restricting things to what we ourselves can just teach students in class and sessions. We are giving them links and resources to go through and bring back their certificates. And we're creating an environment with industry to get them to be able to have hands-on experience with current things that are really happening. Now, so there are lots of projects that we've worked on. And part of what I think we need to do within engineering and industrial engineering in particular is that we need to have research areas. That's what we're also doing here at Price. We need to have research areas that year in, year out, people are working on this same area. And therefore, we are having progress year in, year out. I used to tell my interns that if they gave you the first car that was made right now, you wouldn't be happy to collect it. So the people abroad, the Europeans and the Americans, the Japanese, they didn't get to where they are today overnight. They started somewhere. So if we have research areas within our different departments, and so when people want to do their final year project, the master's project or PhD work, they work in that area. So you have continuity, you have improvement, you have development. And so in a couple of years, you'll be surprised at where you will be having worked for a while. For example, for us, our first suction machine was noisy, power demanding, and all that. We worked further on it. It became more silent, less power demanding. We made it rechargeable, and we made it solar powered, and we improved on it. And when we got to a point, another product came out of it, which is the vacuum and stent closure machine for wound healing. And that one was portable. And every doctor that saw it was just excited. And the Association of Plastic Surgeons in Nigeria were asking for a present that all their plastic surgeons can see this as something they could use. It was better than what they spent a lot of money getting from abroad, which was fixed, big, and power demanding. You have to plug it to a socket and use a lot of power. This was portable. It's handheld. And so patients can actually go to their homes and get treatments continued at their home with these devices if they can afford to rent it out from the hospital and all that. So progress happens once you are focused on an area. Progress happens once you keep. So I feel we should have research areas within our departments that we keep having students flow through, whether for final year projects, master's project, and all that. And a lot can possibly happen in the long run. Then our focus on sustainability. We know a major need in the world at large right now is going for sustainable energy sources, making sure things are renewable powered and all that. So all our products are like that. And I think it should be a thinking that should be incorporated into the idea of our students early. Now, that brings me to talk about the fifth industrial revolution. Now, the fifth industrial revolution talks about sustainability. IIoT with sustainability, CPS with sustainability. And I think industrial engineering is more positioned to talk about sustainability, because sustainability can either be hard sustainability or soft sustainability. You can either completely change things, like Tesla is replacing cars entirely, or you make systems more efficient in their use of resources and all that. So we think around that. Our devices are low energy. I remember the suction machine we made for usage could run for 18 hours non-stop on a single charge, non-stop. And that was big, that was huge. And we were able to get it to use lower energy. So it's easier to power with solar, easier to charge it with solar and all that. So we need our students to be thinking like this. We need to create an environment where they are looking for solutions along this line. So our ventilator is solar powered, our suction machine, our baby incubator is solar powered. All those things that we made is solar powered. And it's really the way to go. So the place of IP in traditional education, I've mentioned that, I've talked about that extensively. IPE has been at the heart of improvement, efficiency, low cost, minimax, and all that. And so much more today, we need to be able to harness the power of CPS to make things more efficient, more reliable, and more economical to run. So we need to change also the spectrum of our learning. IT has to find a way into what happens in IPE. I know we do programming, we do a lot of things, but IT has to come in. The different aspects of learning to give us a multidisciplinary worldview has to come in. We need to look at how to make our, one thing that impressed me that I started seeing that happened in places like University of Toronto and I think Oxford is what you call engineering science, where students are exposed to a wide variety of some things before they narrow down. I know industrial is already vast like that, but we need to pick up a few more things that will make us much more relevant for problem. Example means you need knowledge in computing, you need knowledge in mechanical, you need knowledge in medical, you need knowledge in mechanical, electrical, computer, and medical. All those areas needed to be put together into a single product. So we need to begin to look at how to give our students an interdisciplinary approach to problem solving. Even though we may not be able to give them everything, but if we give them that direction and we lead them, guide them to engage themselves in picking up these competencies, it will do a lot. Research now should be much more interdisciplinary. If we have to bring in people from other disciplines to work on projects together, we need to begin to think about that. Possibly, it shouldn't be just, okay, 5 people in industrial working on a single project. Can we have a project being worked on by somebody in industrial, another person in electrical, somebody from computer is there, and they're working together? We will be solving real problems. Our learning that is narrowed makes us good, competent people that can maintain existing systems. But in terms of innovation, which is what we need in Africa right now, and Nigeria in particular, you need a multidisciplinary approach to be able to innovate. And if you go abroad now, many universities, there are programs, you'll see they're talking about interdisciplinary approach to the learning. So I've talked about incubation hubs, research facilities. We need to look for collaboration with research facilities that could help our students get these competencies. We need to look for how to reach out to research facilities and get them to make inputs into what happens on campus, either virtually, thank God for what the items head has said, virtually or on ground. But it's something we need to think around, something we need to bring in. That's what we do here, and we are seeing a lot of results with it. It's giving us students that are thinking problem solving, thinking solution, thinking how to do things. And of course, the sincere truth is that the African and Nigerian landscape in particular is challenging when you talk about startup. But that's why we brought in for us people like Inyabo Eji, who is very, very experienced in that landscape and is actually a venture capitalist for Africa. He has what you call Future Africa, a venture capitalist to this firm, and his focus is on Africa. His focus is on helping Africans start up. So it's deliberate I brought him here. He's been helping us. and I'm sure if we ask him, like we said in our meeting before now, we want to bring in people that could help IPE and the faculty at large, university at large, to make things. So we could create a situation whereby we get somebody like Ian to come in and give a talk to our students and give them a kind of different perspective to the world, to engineering, to what they're doing, and see it as not just do a course certificate and go and look for a job, but you're thinking, what can I do to change the narrative? So I trust we will be able to achieve this. So there's a lot of responsibility on IPE for profitability and sustainability, which is what is a key aspect of Industry 5.0. So now the final thing I would like to talk about this before I round up is the need for regulatory watch. Now, I'm happy that we have people that are in different positions of authority in different places here. One thing that is important for us to note is the experience during COVID-19. And what happened during COVID-19? The US and even Europe lowered the standard and the requirements in the process of developing vaccines because it was a need. They had no other option. None was existing, and they needed one soon. The approach. If we take that approach, we will be reducing the challenges and the hurdles in the pathway of people coming up with products. You know, I was talking with Innovate, the Israeli embassy initiative in Nigeria, Innovate in Abuja. I was talking with them. And one of the challenges that one of their lead program persons spoke about was the challenge of regulations, all the steps you need to take to be able to get a product to the market, approvals and approvals and approvals. Now, approvals are good, but we need to be able to strike a balance between an approval that can stifle and completely kill an idea from coming out and an approval that helps to guide to get the best that we can get. Because when I look at the American and the European landscape, many of the things they have now and the quality they have now was not there before, but they were using those devices like that. Cars have not always been as they are today, but they use them like that. So we need to get Africa to start off somewhere. While I'm throwing a challenge to the university to begin to think innovation, incubation hubs, research facilities and collaboration, a multidisciplinary approach to learning, and an open learning platform, open learning idea and pattern. We need to also begin to look at what do we do on the end of regulations, and who are those that we can have that would be making regulatory inputs to make sure these things survive. For example, I'm making an incubator for someone in the rural area who will never have access to an incubator. This person is going to be putting the baby in a carton. This is what we have experienced in some of the hospitals in local area that we relate with. In a carton and put a lantern by the side and close it up. Now we're going to develop an incubator that would use sensors and everything and achieve that better. Now, should regulation prevent me from making it available to that baby or allow that baby to die? These are my thoughts, and these are things I felt those of us that are in some positions should begin to look at what do we do about this. So can we have inputs that make it possible that yes, we could use this product if there's none other available? It must not meet the standard of the one coming from outside, but if there's no other one available and it can help, can we do regulations that make it possible to do that? That will indeed help us and help our students graduating with ideas to be able to meet needs and hit profitability, because many times regulatory hurdles and that timeline and all that make it challenging to actually hit profitability and for a product to go to the market and be sustained. So in conclusion, CPS represents a pivotal advancement in engineering, offering transformative capabilities across various industries. By leveraging the diverse platforms available for learning about CPS, we can stay at the forefront of technological innovation and drive meaningful advancement in our respective industries. Thank you very much.
Thank you so much, Engineer Shin. That was a very brilliant session, enlightening, definitely worth all the expectation that was building up before you started speaking. And I'd like to particularly appreciate everyone in the audience for paying attention and staying through, listening to everything that has been said. There was something for everybody, something for students, something for policymakers, something for lecturers, something for people in the industry. It was a very robust, I think that's the word, robust and packed lecture. And we can understand why it had to extend beyond the allotted time. Well, thank you so much, sir. Right, we already have a question in the chat, but it's not, we'll come to questions after we have our chairperson, Engineer Bello, just give a quick remark on the talk. If you are still here, yes, he's here. Engineer Bello.
Thank you, Madam Moderator. Thank you very much. I really appreciate the lecturer, but for the beautiful presentation you have this night. I have to make a sacrifice. I need to choose between my president chat talk this evening, because, as I said, after the council meeting yesterday, the president said he wants to talk with all the members. So I have to go to be there. So I have to make the sacrifice to be here too. However, we appreciate our guest speaker for the beautiful lectures and for the insight he shared with us. Something come to my mind when he was talking toward the end of the lecture regarding the act or something like that. If I would like to talk to the guest speaker after the lecture, because as the branch chairman, our president encouraged all this kind of innovation and the things that can bring better development for the curriculum in our schools and our environment. And from the NSC side, we are going to support our guest speaker. In fact, I would like to meet him after this program, if you can come up with a kind of memo to the council for them to encourage CPS in our curriculum in the universities and other places. And not only that, I would like to collaborate with this guest speaker in my branch, by the branch, with the premier branch. Maybe probably during our engineering week, I can have a way of putting this lecture in one of our young engineering programs, if you can come down to deliver the lecture again. So I don't want to waste most of our time. Let's give room for the people that want to ask questions. And also, I want our colleagues from the current aspect, from the correct side, to make input as regard the act the guest speaker is talking about, so that I believe this thing will help Nigeria a lot. Not only for the students, even for the graduates. Outside, most of them they are jobless. If I have a way of encourage them, where my brand partner with the guest speaker can train most of these graduates, even some corpers. Because most of them, when they send them to secondary school to go and teach, they come back to the branch to look for where they can post them. So I believe this kind of topic, CPS, help a lot to encourage our young graduates and students to make a better living and for the development of the country. It talk about the smart grid and energy management. I work in power system in transmission. Nigeria is working toward making our own grid smart, so that we avoid all this kind of incessant system collapse. You know, if all our generations and some of our discos have a smart network, we have little of collapse in the country. Because take, for instance, most of the generations, some of them don't have free governor system. We can react to any sudden loss of a higher megawatt. I don't want to go to that. Let us just continue our lecture. So I thank you for the opportunity to be the chairman of this occasion, and let's give our audience opportunity to ask questions for our guest speaker to respond. I also appreciate our guest speakers, our special guests of honors. In fact, I appreciate Professor Victor Oyedokun. He is a very brilliant person. He is a key member of the branch, and they have been encouraged our youth. He's one of our guest speakers in the March general meeting. So I appreciate him for this wonderful opportunity to present as the chairman of education. Thank you very much, Madam Moderator. Thank you. Can go ahead.
Yes, thank you so much, sir. And we're happy that we were able to make it worth your sacrifice. Thank you for staying. I would like to quickly give the director of items a minute to speak. She was acknowledged in the talk a number of times. Just like to give her a minute to respond to the talk if she's still here. Yes.
Yes, thank you very much, moderator. You're right. I am particularly impressed and blessed by that talk. So again, I want to appreciate the lecturer for that brilliant presentation. A few things were highlighted during the presentation that I think we would like to take further. There was the mention of some certifications and trainings online. And we have a training unit that is interested in developing student capacity and prepare them for the workforce, even while they're in school. So unfortunately, we also started a discussion with Cisco for the establishment of a Cisco Academy in the university. So we would like to take this further and see how our students can start benefiting from this. We had also thought of some courses like the CPS that could be that would not count towards the credit of students when they start, before all the formalities of taking it through the necessary policies to make it part of the curriculum. I feel we can actually start with that as a no-unit course, so that students can take this online and start from somewhere, while all the other details and strategies for making it part of the curriculum is ongoing. So that won't stop us. I think we can actually start even now. So I want to appreciate the lecturer once again and thank everyone for the opportunity to be part of this.
Thank you very much, ma'am. The special guest of honor, Professor Olorunmaye, I would like to welcome you to also give a few remarks.
Thank you. Can you hear me?
Yes, sir, I can.
Very good. I thank the IP alumnus for this brilliant lecture. And he has touched on some things that are relevant to us as we think of reviewing the current BMAS, particularly that one extra semester we want to bring back to the classroom so that the 6-month IT will be reduced to 3 months IT. During that second semester, one of the important courses there will be engineering project 1. When we are supposed to use he has even suggested to us this evening that where possible, we should have multidisciplinary groups solving real life problems from the industry. So I thank you for these suggestions. We hope the HOD of IP at UI, we hope you'll be available to work with us in fine-tuning the curriculum for industrial and production engineering when we call on you to assist us, making use of these ideas and weaving all this into the current curriculum review. Thank you.
Thank you. Thank you so much, sir. I'm also very happy to hear that this talk is going to translate to real change that will be seen in the in academia, and I'm looking forward to all that would come out of it. A name that came up a lot during Engineer Sheon's talk was Iyolua Boyeji. I'm a fan. I don't know if anybody else here is familiar with him, but sir, if you are here, would like to just have you also respond to the talk, maybe comment and end with your question that is already in the chat section. I don't know if he's still here.
He's still here. Maybe if he turns on his video.
Okay, I've asked him to unmute. Maybe he's not available at the moment.
Hello, can you hear me?
Oh, yes.
Okay, can you hear me?
Yes, sir.
Okay, my camera now. I was in a noisy place, so I had to move away a little bit. But I've been listening, and it's been such a pleasure to connect, and I'm looking forward to the collaborations. Did I miss a question?
No, you sent in a question earlier.
Yes, I did. A while back, I had asked. I was asking the guest lecturer whether we have some sort of standard checklist for setting up these cyber physical spaces, so that people can partner with him to set it up wherever it's needed. So I was hoping there was some sort of checklist. But, I think the speaker has done justice to the topic and talked through quite a number of the issues, and maybe that's something we can further develop together.
All right. Thank you very much, sir. Engineer Sheo, would you like to respond to that? Would you like to answer that question?
Yes, so it's CPS requirement is broad. It's very broad because, for example, if you get to a place like Edinburgh, you have CPS for pharmaceutical, CPS for medicine and all that. But there are some basics which we can put together. There are some basics, BRS minimum, in terms of what is required to set up the system. And like he has said, as we are interested, we can help put that together. Already, I'm with IPE, so it's just for us to decide, oh, this is what we want to do. I've always been coming around to make inputs, and we can do that together.
All right, sir. Now we'll throw the floor open for questions. Other questions? I know there was a hand up before. I know Engineer Folabi Babarin, sir, wanted to ask a question. I don't know if he's still here. So if you have any questions, you could just raise your hand and you'll be given an opportunity to speak. Otuto, I don't want to mispronounce the name, but I would unmute. I would ask to unmute Chuku Ocha, I hope.
Yes. Can you hear me now?
Yes, sir.
Okay, thank you so much. My question, sorry, I joined a bit late because I was on the road when I was supposed to join. My question goes to, I think, please, CPS, we are talking about engineering.
Sorry, you're muted.
Can you hear me now?
Yes.
Okay. I'm talking about CPS, right? The cyber physical structure. Now, you are talking about engineering mainly, maybe because that's your field. But you also were talking about synergizing, being able to collaborate. You talked about IPE. So my concern here is how do we start that? let me come this way, because all we are dealing with is how to improve the economy, how to improve the system, how to make sure that things are working in Nigeria. Now, does CPS apply to areas like real estate? Does it apply to areas like, I know there's a lot of engineering in farming. Does it apply to areas like that? How do we collaborate with these other areas to ensure that one arm of the economy, when we start, is not left behind, and then it's the rest of the knowledge that should help grow that aspect as well? Thank you.
Engineer Sheung.
Okay, thank you, Dr. So you are very right in thinking about the possibility of the application of CPS in other areas. Of course, the areas I mentioned before on the slide, includes healthcare, agriculture, apart from manufacturing. It actually gets into all the transportation everywhere, all the education everywhere. So like we have virtual teaching and things like that. So it transcends everywhere. And the first thing that is critical is understanding the system and being able to apply it. Like I said, we say to our students, we can't teach you everything. Sorry, am I being audible?
Yes.
Okay, great. You sorry, somebody's talking. Can we mute? Okay. So we can apply it to everywhere, but like I say to our interns, we can't teach you everything, but we can teach you how to learn everything or anything. We teach you how to learn. So there is that basic understanding, looking at the student angle, that idea we can put together for them that makes them able to scale it into anywhere. It's all about, looking inward, looking at an environment and deciding, so, okay, for example, I had an experience back in Nestle Foods in 2000 when I went there for my IT. And I went there with an idea that I want to apply what I've learned to solve a problem. I don't know what problem it will be, but I just believe that there must be a problem in Nestle Foods that I can help them to solve. So I went around just 3 months. It was 3 months. I spent the first month going around looking at things. And then by the second month, I saw the Milo production line. I did a work study of it. I observed that, okay, something may be wrong somewhere. So I was applying what I had learned back in school, work study, to the Milo production line. In the end, I put together a proposal for them on what they need to do to improve the system, submitted it to the factory manager and all that. And then there was another project like that I came up, something to help them with the Maggi packing machine that I designed. And it was all about seeing a problem and seeing how the tools I've learned can come into solving that problem. So that's what I see with CPS. So for example, in real estate, talk about smart buildings, talk about developing efficient estates in terms of energy usage, in terms of optimizing things generally. It's there. Right now, there are buildings that are called green buildings in terms of the percentage to which they are energy efficient, to which they are able to optimize things and make life easier, ergonomic, and all that all together. So CPS definitely transcends that. So you have buildings that are connected, buildings that can be talking to the server, talking to the cloud, getting information back and taking decisions based on what happens in the building. So that is happening in real estate and can happen with us very much in Nigeria. And to make things more economical, more efficient. You have buildings that once you step out, some devices shut down and power is reduced and all that. So air ventilation, control, and all that, design, everything. And you're using AI to analyze, okay, so which direction should this building face for the whole year? What data do I have about wind flow and sun rays coming and all that to determine how can I locate this building to make it cool and all that? You're crunching data and you're doing all that. It's possible. Thank you very much.
Thank you, sir. So the key takeaway there is to just have an open eye for problems, and be able to synthesize with the knowledge you have acquired. Oh, to just take this last question from Engineer Falabi Babarin, sir, before we wrap things up.
Okay, thank you very much, moderator. Sean, you've really done very well. So fantastic. It's a very good, very good topic. There is one area that interests me, which I would like to ask question, if it is possible. That is the area of this, your smart city. It's something that is going on now. If you are, or your team is invited to co-work on a property to develop smart city with large expansive land, but probably maybe we can start with like 10 buildings to see how it's going to work. How can we meet with you and talk with you? Probably maybe I can speak with the HOD who has been giving me inroad to those I would like to talk with. Can I go through him so that I can get in touch with you?
Sure, sir. You can do that, sir. We'll be ready to talk with you on that. You can go to the HOD, sir. You can.
All right. Thank you very much.
Yes, sir.
You're welcome, sir. I personally and my team, we appreciate what you have given to us this night. It's awesome. Thanks.
Thank you, sir.
Thank you. Thank you very much, sir. So now I think we'll just take your closing remarks. There are no other questions. But for anybody that is wondering, Engineer Sheon is Director of Peace House Research and Innovation Center. So that's what he has been calling PRICE, in case anybody was wondering what PRICE is. So I'm sure you can find him online. But I'll just allow you to give it your closing remarks, closing remarks now. Yes, sir.
So sorry, I didn't get the last thing you said. I should just go ahead my closing remarks.
Yes, just your closing remarks.
All right. So as a close, I want to say I came to this presentation and with all my heart, because I'm passionate that it's possible to change Nigeria. It's possible to begin somewhere. For me, from the Bible, for example, a little level levels the whole lump. If we start small, we can go far if we are passionate. I'm so excited about IPE and what we are doing. I'm excited to see the donations coming to departments, people bringing in that act of giving back and all that. I believe that if we don't give up, we can actually cause change. What I want to say to the students listening to us is, yes, there's a big problem in Nigeria, but it depends on from what angle you see it. The fact that dollars are no longer available simply means that people will have to do with products that are available here. So where somebody sees a problem, another person can see an opportunity. Rather than sit back and complain, we could decide to make some change. And I trust the Lord will help us. Thank you very much. I want to say a special thank you and appreciation to Engineer Bello, the chairman of NSC Ibadan branch. I'm so excited that they were able to make it. Engineer Prof. J.A. Olorumaye, thank you very much, sir. The chairman of Koren, EAC, and Mrs. Abiodun Alao. I was excited about our input. And my friend, Padare, thank you so much. And many thanks to our HOD for giving us this opportunity. I want to particularly say thank you to Professor Ayodeji Oluleye. He's been a role model for many years, since back in the day when we were in UI. Thank you, sir. Thank you very much, Dr. Over to you.
All right. Thank you so much, sir. I'd like to call on the person that will be giving the votes of thanks. But before then, I would also like to thank everybody that came with Engineer Sheung. Thank you for coming with, listening to, and staying through till the end. Please follow us wherever you can so that when our next event comes up, you would also be in the know, even though he might not be the guest speaker, but whoever it is would be somebody you want to listen to. So I would like to welcome our lecturer in the department, Dr. Adeyeye, to give the votes of thanks. While we're waiting for him to come up, I'll just announce the topic for the next talk. The next talk is something very interesting, a bit different from what we're talking about. But okay, Engineer Adeyeye is here rather. Yes.
Yeah. Ladies and gentlemen, there is no doubt that the lecturer has done justice to this topic. Cyber physical systems, a new direction for higher education in Nigeria. And of course, it's already resonating. He has given us experience in price, at no price. The lecture is really loaded. The components, the applications, and when I listen, I could see that it affects all phases of human endeavor. And its application in education, the challenge it has thrown to those of us in academics and other spheres of life. The chairman of current accreditation committee is here and is already resonating. The chairman of, the director of items, and also the alumni, both in Nigeria and in the diaspora, has challenged us to harness their competencies and expertise. And of course, what happened tonight is a testimony to the fact that the alumni is a gold mine for us in the department and also for the nation. I'm in short of words to really express our appreciation to you for this insightful lecture. Thank you for honoring this call to give this lecture, and we look up to collaborating with you in future. We also appreciate the people who also came with him, the head of leadership and entrepreneurship in person of Tope Adeniyi, Mr. Aboyeji, the co-founder of Flutterwave, Mr. Lasisi, and Professor Adeoye. Thank you for making up time to be part of this lecture. We are very, very grateful. We also appreciate the chairman. We thank you for this honor, despite other commitments. Not only did you come, but you also stayed to the end. We also appreciate your contribution to this lecture. Your comments are very, very insightful, and we appreciate it. We are grateful to our special guest of honor, Professor Olorumaye. We also thank you for the steps you have already taken, and we are looking forward to see the outcome. We are grateful to Mrs. Abiodun Alao also for your contribution and your commitment to make use of things we have gleaned from this lecture. We are grateful to the head of department, Professor Oladokun. We are grateful to the IPEAA Alumni Lecture Series Engagement Team for your relentless effort to ensure that this lecture continue from time to time. And all the people who have attended this lecture, we are very grateful. Those who have asked questions and made comments, you have shed more light into this, and we appreciate your contributions and your presence has add value to this lecture. And our able moderator, thank you very much for everything, for your presence, and you have actually moderated very well. And our father in the house, Professor Oluleye, thank you for being there for us at every time. We are very, very grateful. Thank you, everybody, for attending this lecture. Thank you for your contribution. We look forward to seeing your face in the forthcoming ones. Thank you, everybody, on behalf of the department, on behalf of the alumni, and on behalf of the IPEAA engagement team. Thank you.
Thank you so much, sir, for that vote, for the vote of thanks. Thank you. So you mentioned looking forward to seeing people in the next series, and I echo that. Next month in August, on the 9th of August, we'd have the 23rd Alumni Lecture Series, and the topic is the future of financial technology, trends and opportunities. So we heard from Aboyeji, who is the co-founder of Flutterwave, one of the biggest, if not the biggest fintech company in Nigeria. But that space is very open and there are lots of opportunities there. And we'll have next month, I'm sure that we would all be learning how we can tap into that regardless of the sector that we might be operating in. So mark your calendars to be the 9th of August. That's the second Friday in the month of August. And it will be an enlightening session as always. I'm sure everybody that comes here can attest to the fact that there is always something to learn when we gather here like this. So make sure you plan to be present and also invite people that you think this topic would appeal to or would interest in one way or the other. Finally, you can follow us on social media just so you are in the know of everything that is happening. Twitter, LinkedIn, and Facebook. You can find IPEAA to stay up to date on everything that is happening. The speaker for next month is Munachi Ogweke. He's the CEO of One Liquidity Limited. From the set of 2017, IP set of 2017. So set of 2017, I don't know if anybody is here present, but one of yours will be speaking. It would be lovely if you all come out to support your classmates as he delivers the lecture. So thank you to everyone. We have stayed beyond the allotted time, but it was definitely worth everyone's while. I'm sure everybody would agree that we learned a lot and it sparked a lot of hope in our hearts for the future of Nigeria. So it's definitely time well spent. I hope we all have a lovely, lovely weekend and see everyone again next month. Bye.
Yeah, thank you very much. We appreciate what you have done.
Thank you, sir.
And I believe the next person